Welcome to Matematika. Today we're going to do the lesson 1.3, which is the rates of change in linear functions. Actually, that's rate of change in linear functions and quadratic functions. But what I'm going to do here, I'm going to do it by part by having the rates of change in linear functions first. So in my next video, I will be going to do the rates of change in quadratic function. So we'll start with the definition of a linear function. So of course, it's a function that has a constant rate of change. So the rate of change here is constant. The slope that is related to the rate of change, because when we say rate of change, we are talking about the slope. The slope is the ratio of the change in the vertical direction, that is the y direction, and the horizontal direction, that is the x direction. Okay? Vertical y, horizontal x. How does a linear function represented? So it can be graphically, it can be by using a table. There are so many ways. So as we go on in this unit here, I can show it to you the different ways a linear function can be represented. So we're gonna do it graphically. So using the graph, we can see a linear function. It's always a straight line, because if in the graph it's not a straight line, then that is not a linear function. One of the defining characteristic of a linear function is its constant rate of change. This is because the rate of change is always the same over every interval of the function. And that's, when we determine the slope. Okay, let's look at it. All right, we'll start with graphically. Looking at this graph right here on the left side, right, I can make this a little bit bigger. Okay, we know that the slope, when we look at the graph, it is rise over run. All right, we know that. So in this case right here, it is shown that here the rise is 4 and the run is 2. That means the slope is 2. If we look at this one, it goes up 4 and then over 2. That means still the rise is 4 over 2. All right. The slope, okay, the rate of change, all right, is constant. You see this? 2, 2. Okay. Sorry for that. Let's look at the table. All right. Let's say in the table you have the x, the input, with the interval from -3 to 2, and the output, this is the input, this is the output. That is the horizontal and vertical direction, as what the definition means. All right. By looking at the table, we we'll get the constant. We'll try to get the constant rate of change. Let's see if the rate of change is constant. What are we gonna do here? By finding the first difference. If it's in the table between, where do we get those difference? Between the output value, the f of x, right here. Okay, let's start. So if I say I will get the difference from this interval, okay, so what I'm going to do is I will get the difference. So -3 minus -5. Okay, so what will happen? That would be -3 plus 5. The answer is 2. All right. If I get the difference with this interval, so that would be -1 minus a -3. So that would be -1 plus 3. You come up with 2. How about this interval? Okay, so I'll have 1 minus a -1 equals 1 plus 1. That's equals to 2. How about this interval right here? So the rate of change is 2, 2. How about this interval? So I have 3 minus 1. So it's equals to 2. Still equals to 2. How about 5 minus 3? That still equals to 2. So what can you say about the rate of change? So the first, it's always 2, constant. So you could say that the first difference, all right, the first difference are constant. Be sure you can make some statements when you do or you're asked to explain. Okay, so what does it show? It shows that what? That the constant rate of change, it shows constant rate of change. So the rate of change here is constant. Okay, so what the formula to calculate the rate of change? What's the formula that we use to if ever you are given a problem, as we had in our 1.1 and 1.2, we always use the change in y, that is delta y, over the change in x. Okay, so we have delta y over delta x, that is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If 2 points are given with an equal interval, then you can find the slope by using the formula to calculate the rate of change, or we call that the slope. Okay, let's look at more on if you are given a certain graph, whether it's a positive or a negative slope or is zero slope. What is going to happen? What can we say about the constant rate of change with that kind of graph? Okay, let's do this right here. Okay. Find the average rate of change of each linear function. So linear. If if I will be asked, and then there is in the question, and there is nothing, there is no other question rather than asking you to find the average rate of change, I could tell right away with this that this is the slope, right? I know that the slope is 2/3. Okay? So from here, if you are asked, okay, why don't we check or verify if it is really 2/3? All right, let's do this. So we know that it's 2, it rise 2/3. It run. So rise 2, if I use this as the rise, and then this is the run, this is my first point right there. So rise 2, run 3. All right? With the interval of what? What is my interval here? With the interval of 0 to 3. All right? So the rate of change is 2/3. All right. I will choose another one. If I choose this point right here, I rise 2 and then over 3. So what's my interval here? From 2 to 6. That's the interval. I still get the 2/3. So I think that's enough for me to show whatever points you're going to choose on this line, you come up with the slope or the rate of change as 2/3. Okay. Now, if we try to get the average of that rate of change, let's get the average. If ever we have all of this will be 2/3, that means I get the average of 2/3, then another 2/3, and we expect another 2/3. What is the rate of change of the average rate of change in the linear function? Is it at its 0? Okay, nothing. It's constant. I mean, the change in linear function is 0. All right, let's do this. In number 2, we could tell right away that the slope is -2. I could tell without using the graph. You are just given the linear function. All right, it's negative. That's why your line is from top left going to down to the right. All right. So what does the slope means? It's -2/1. That means it goes down 2/1. So let's say I choose this point right here. All right. Or this point right here. So it goes down 2 and then over 1. Right here. 1. Right. If I choose another point, it goes down 2. What is my interval here? I have an interval of -1, 0, or 0, -1. That would be the interval. If I have go down 2/1, because it's negative, that means down 2, the rise over run, going down 2 over 1. So with the interval from 0 to 1, what do I have as the, what is negative 2 over 1? That is negative 2, right? This is negative 2 over 1. That is still a negative 2. So I have the rate of change as negative 2. If I will get the rate of change of the average rate of change, I will expect that there is another negative 2 here. So the rate of change of the average rate of change will be, this will be 0. Okay, that is what we mean with that. In number 3, okay, what do we have in 3 right here? If I choose any point, of course, you see horizontal line. There is no slope. There is no rise over run. Right? Okay. So that means, let's say from point negative 2, negative 1 as my interval, there is no rise. That means the rise is 0. And you have a run of 1. Still the slope is 0. Or the rate of change is 0. And let's say I choose 0 to 1. Okay, my interval here is, let's say negative 2, negative 1. Slope is 0. If I have the interval of 0 to 1, I still have the slope of, there's no rise. The run is 1, so it's still a 0. That means if your rate of change is 0 all throughout, 0, that means the average rate of change for a linear function is constant. Okay? It is constant, always constant. And what does it say? That the rate of change of the average rate of change of a linear function is always 0. Okay, let's put that into writing. There are 2 things that we have to remember. About the average rate of change for a linear function, it's constant. Right here. It's all 0. It's all negative 2. It's all 2 over 3. Constant rate of change. But the rate of change of the average, so we are trying to get all the average rate of change. What will be the rate of change of the linear function? We can see, we check that it's 0. It is 0. And it is 0 right there. So that is why it says it is 0. Okay. Let's put that into application. Let's apply that the rate of change would become 0. And the rate of change is constant. All right. Let's do question 4. What is the rate of change of the average rate of change of this linear function over consecutive equal length interval? So that means the interval are equal in length. Okay? So for example, in A, y equals 13x minus 10. Okay? Equal interval. The rate of change of the average. You see that? rate of change of the average rate of change. So what is it asking about? That the rate of change of the average rate of change of linear function is 0. That means the average rate of change here of the rate of change of this linear function is 0. Okay? Right there from this statement. Okay. The other question, B and C, is asking about what is the average rate of change for its function on the given interval. That means you are asked with the rate of change. We know from this statement that the average rate of change of average rate of change for a linear function is constant. Okay, we know whatever we have an interval, but regardless to that interval, we know by looking at this linear function that the rate of change in B is 7 and the rate of change in C is 5, because the rate of change is constant regardless of whatever interval that is given. The rate of change is constant. So if you will be shown like using the interval of from -6 to -4, your rate of change or the slope will always be constant. Okay, always 7 in this linear function, 7x plus 10, in the linear function of 5x minus 3, regardless of the interval that is given, the rate of change is 5. All right. Let's look at this in another perspective. Okay. Question 5. The function f is a linear function with f of 6 minus f of 2 equals 20. What is the rate of change, okay, of f? Now, when you can see that function of 6, function of b, there is, we should not neglect the formula for the rate of change that we have been using. That's the function of b minus function of a equals b minus a. Remember, we do that in the rate of change lesson. Okay, since we are given here an f of 6 and an f of 2, we are given a function. So we are going to use this to find the function of f in a linear function. Okay, what is the rate of change? So we're going to use this formula. All right. Let's do this. Let's make that if we are given an f of 6 and the function of 2, so we can make that as 2 to 6 interval. So we can make this as the function of b. We can make this as the function of a. So our a would be 2, the b would be 6, right? So we're going to do this using the formula. That's the function of b minus the function of a over b minus a. Let's substitute. Okay? It says, okay, I'm going to substitute first. So f of b is f of 6 minus f of 2. That's a. So b would be 6 minus 2. Oops. All right. But it is given here. What is the function of a 6 minus the function of 2? It's given in the problem that it is equals to 20. 6 minus 2 is 4. So our rate of change is equals to 5. That's it. By using that formula. So our rate of change is 5. Okay. How about if you are given in letter B, find f of 10 minus f of 6. Alright? So, still using the formula of M, f of B minus f of A over B minus A. So, I could say that our A, okay, our slope here is 5. 5 is given already. All right, we are using the same slope here. I could make the B would be 10, A would be 5. Oh, A would be 6, sorry. Because it's F of 10 and F of 6. Okay, so A is 6. All right, let's substitute. So what will be our F of B? Is F of 10. And our F of A is F of 6. Okay, let's do this in the formula. So our M is 5. Then F of 10 minus F of 6 over 10 minus 6. Okay, you have that. 5, we are looking for this. Remember, F of B, F of 10 minus F of 6. So F of 10 minus F of 6 over 4. Okay? All right. So what do? We cross multiply or multiply 4 on both sides. So 4 times 5, that will be equals to 20. That is F of 10 minus F of 6. So in other words, we could say, so we answer the question. The F of 10 minus F of 6 is equals to 20. That answers the question. All right. Let's do question C. Find F of 27 minus F of 14 over 5. Okay. Let's sort out what we could get from this information asked. So the rate of change is 5. I could make the A as, because the interval there is 14 to 27. So A is 14, B is 27. F of A is F of 14. And then F of B is F of 27. Okay, let's do this in the formula. F of B minus F of A over B minus A. All right. If there is certain given function and interval, then we can use this formula right here. So our slope is 5. Let's substitute. F of B is F of 27 minus F of 14 over 27, which is the B, and A is 14. So 5 okay, so 5 is F of 27 minus F of 14. What is 27 minus 14? That is 13, right? So multiply 13 on both sides. 5 times 13, that is equals to 65. That is F of 27 minus F of 14. But this doesn't answer the question. Find F of 27 minus F of 14 over 5. So what would that be? Okay, it says find F of 27 minus F of 14 over 5. Okay, so what do we have? We know that F of 27 minus F of 14, we know the value, and that is equals to 65, right? And then you divide by 5. 65 divided by 5, that's equals to 13. That is the value of F of 27 minus F of 14 over 5. I hope everything is clear. We will do more on problems with solutions as we finish the lesson. In my next video, I will be doing with quadratic functions. Then after that, I will have more problems and solutions on rate of change of linear functions and quadratic functions. So let me say this. If I can do it, so can you. All right, don't forget to hit the like button and please hit the subscribe. Thank you. See you.